Light looks calm, silent, harmless. It fills every corner of your day without asking for attention. The glow from a screen, the warmth of sunrise, the sharp colors that define the world around you. It feels ordinary, predictable, almost boring. But beneath that quiet brightness lies one of the strangest behaviors in the entire universe. Because the moment light begins to travel, reality stops acting the way common sense says it should. Scientists spent centuries trying to understand it, and each discovery only made things more unsettling. Light moves faster than anything that exists. Nothing with mass can catch it. Nothing can outrun it. It is the ultimate speed limit of the cosmos. Yet under the right conditions, light slows down, not a little, dramatically. It bends away from a straight path. It shifts direction without warning. It can even force time itself to stretch and shrink. These are not theories meant for science fiction. These are measured, tested, proven effects that quietly shape every second of your life. The deeper researchers looked, the clearer one disturbing truth became. Light does not simply travel through reality. It controls the rules that reality must follow. When scientists discovered that the speed of light never changes, no matter how fast the observer moves, physics faced a crisis. The equations refused to work unless space and time themselves were flexible. That meant clocks could tick at different rates. Two people could experience time differently. A fast-moving traveler could age slower than someone standing still. This sounds impossible, yet modern technology depends on it. GPS satellites orbiting Earth must constantly correct their clocks because time flows slightly faster for them than it does on the ground. Without those corrections, navigation systems would drift off course within minutes. Every route you follow is quietly guided by the strange behavior of traveling light. Then comes another hidden layer. Light tears across empty space at full speed, but the instant it enters glass, water, or even the air under certain conditions, it gets delayed. Not because something grabs it, but because it interacts with tiny charged particles called electrons. Each interaction causes a microscopic pause before the light continues forward. The result looks like slowing down, as if the universe briefly placed invisible obstacles in its path. This bending of light is the reason a straw appears broken inside a glass of water. It is why lenses focus images. It is why rainbows form after rain. Some of the most beautiful sights on Earth are created by light changing direction. Push the story further, and the strangeness grows. At speeds close to light, objects no longer appear normal, length contracts, motion distorts, shapes can look twisted, almost unreal. Experiments confirm it again and again. Reality is far less rigid than human intuition suggests. The world feels stable only because people move far below light speed, step closer to that limit, and the universe reveals a completely different personality. In this video, you will uncover the surprising ways light reshapes space, bends paths, and alters time. You will learn why the fastest thing in existence can still be delayed, how invisible interactions guide the images you see, and why some of the technology you rely on would fail instantly if these strange effects were ignored. Most importantly, you will begin to see that the familiar glow surrounding you is not simple at all. It is evidence that the universe operates on rules far beyond everyday perception. Stay with this journey until the very end, because the final realization changes how light and reality itself will look forever. Once these ideas settle in your mind, even the most ordinary beam will feel mysterious again. Welcome to our channel, where the universe becomes clearer and sometimes far stranger than expected. If discoveries like this spark your curiosity, make sure to subscribe and join us for more deep insights that challenge the way you see the world. Most things in the universe refuse to move unless something pushes them. A parked car stays still until an engine fires. A ball does nothing until a foot strikes it. Motion usually demands force. This rule feels so basic that it almost sounds like a law of reality itself. Yet light quietly ignores it. No engine, no fuel, no shove. The instant light exists, it moves. Not slowly, not gradually. It launches forward at the fastest speed nature allows, the cosmic speed limit. Through the emptiness of space, it travels without resistance, crossing enormous distances with perfect consistency. Scientists discovered something even harder to accept. Speeds normally add together. A thrown object inside a moving vehicle appears faster to someone watching from the outside because the motions combine. Light refuses to follow that logic. No matter how fast the observer moves, the measurement remains the same. Even at extreme velocity, the beam does not appear slower or faster. It holds its speed. This strange behavior helped inspire Einstein's theory of relativity after experiments failed to detect any medium that light needed to travel through. Now the mind hits a wall. If the speed of light never changes, then the universe must bend its own rules to protect that constant. The equations left no alternative. Space could not remain rigid. Time could not remain absolute. Something had to adjust. That something turned out to be time itself. As motion increases, time begins to stretch. A clock in fast motion ticks more slowly compared to one at rest. This effect is called time dilation, and it is not a philosophical idea or a thought experiment. It is measurable reality. The faster an object moves through space, the slower it moves through time. Evidence for this is not locked inside laboratories. It is orbiting overhead right now. GPS satellites depend on extremely precise timing, and relativity constantly interferes with their clocks. Because of their speed and weaker gravity at high altitude, satellite clocks gain about 38 microseconds every day. Without correcting for this tiny difference, navigation errors would grow rapidly, making positioning unreliable within a short time. A few microseconds sound harmless, yet the consequences are massive. Errors would expand into kilometers, routes would drift, systems people trust every day would quietly fail. One of the strongest confirmations of relativity is not hidden inside advanced physics. It guides travelers, pilots, delivery drivers, and emergency services. Light does more than illuminate the world. Its constant speed forces time itself to behave differently. Pause for a moment and let that settle in. Light is not just passing through space. It is rewriting how time flows. Shift attention now to something far more familiar, a glass of water on a table. Place a straw inside, and it appears bent, almost broken at the surface. The straw has not changed shape. The illusion forms because light changes direction as it moves from air into water. When light enters a different material, it slows down and bends, a process known as refraction. American Museum of Natural History, 3. The cause sits at a scale too small to see. Light is an electromagnetic wave, and when it moves through a material, it makes charged particles, especially electrons, vibrate. Those vibrating electrons emit their own waves that combine with the original light, creating a new wave that travels at a lower speed. Nothing grabs the light, nothing blocks the path, yet the journey takes longer. Once the light exits the material and returns to empty space, the delay disappears and it resumes full speed again. Think of it like moving through a crowded hallway. Forward motion never fully stops, but every interaction steals a fraction of a second. Step after step, the destination remains ahead, just slightly postponed. Another subtle detail makes the bending happen. When light enters a new material at an angle, one side of the wave slows before the other. That uneven change forces the path to tilt. This single effect shapes countless experiences. Lenses guide light into human eyes, so images can focus correctly. Magnifying glass surfaces bend rays until objects appear larger. Even the distortion seen through curved bottles comes from the same hidden rule. The deeper this behavior is examined, the stranger it feels. The fastest thing in existence can be delayed without being stopped. Straight paths can curve without warning. Time itself can stretch simply to preserve one cosmic speed. Nothing is physically holding light back, yet it still arrives later. When light moves from one material into another, direction itself can begin to warp. The change is subtle, but the consequences shape nearly everything the eyes experience. The reason traces back to the behavior of waves. As light crosses a boundary at an angle, from air into water, for example, one side of the wave slows before the other. That uneven slowdown forces the entire beam to pivot and continue along a new path. This bending has a name: refraction. It is not a rare effect hiding inside laboratories. It is active everywhere. Light also travels more slowly inside materials because it makes electrically charged particles, especially electrons, oscillate. Those oscillations produce new waves that combine with the original light, creating a wave that moves at a reduced speed. The moment light leaves that material and returns to empty space, the slowdown disappears and its full speed comes back. Such a tiny interaction builds the foundation for powerful tools. Lenses depend entirely on controlled refraction, bending light so images can sharpen instead of blur. Without that guidance, eyes could not focus properly and cameras would fail to capture clear detail. Even rainbows owe their existence to this same principle: light shifting direction as it passes through droplets and separates into colors. Invisible physics is quietly organizing every scene you look at. Nothing about the world would appear stable without these constant adjustments happening at the speed of light. Push deeper, and the behavior grows stranger. Approach the speed of light, and reality begins to abandon familiar shapes. Objects moving extremely fast are measured as shorter along the direction of motion, a phenomenon known as length contraction. This is not noticeable at everyday speeds. The effect hides until velocity climbs close to light itself. Only then does the shrinking become significant. Proper length, the size an object has when resting, no longer matches what observers detect during high-speed motion. The faster the travel, the smaller the measured length becomes. At the extreme limit, theory predicts something almost unthinkable. If an object could reach light speed, its length in the direction of travel would approach zero. Yet the visual story can become even more unsettling. Because light from different parts of a fast-moving object reaches an observer at different times, the object may appear rotated or distorted rather than simply flattened. It can look twisted, misaligned, nearly unreal. Not a glitch, not an illusion created by faulty instruments, just the geometry of space-time revealing itself. There is a deeper structure connecting all of this. Every strange result, bending paths, shrinking lengths, stretching time, traces back to one requirement: the speed of light must remain constant. That single rule forces space and time to adjust whenever motion becomes extreme. The universe, then, is not the rigid stage it appears to be. Distance can compress, duration can expand, straight lines can curve. What feels solid is more flexible than instinct suggests. This pattern keeps repeating. Increased speed, and time slows relative to outside observers. Increase speed further, and measured distances contract. These changes are not mechanical failures. They are built into the structure of reality itself. High-energy particle experiments must account for these effects, and even astronomical measurements consider them when studying fast-moving objects across space. The more closely scientists examined light, the clearer the hierarchy became. Light is not just something that helps the universe stay visible. It sets the boundary that everything else must respect. By establishing the ultimate speed limit, light determines how motion behaves and why relativity emerges in the first place. Remove that constant, and the equations that hold modern physics together would unravel. Measurements would lose agreement. Predictions would collapse. The structure linking energy, space, and time would no longer remain consistent. So the next time brightness fills a room, remember what is really passing through that space. Not just illumination, but the very rule book that motion, distance, and time are forced to obey. The strangest truth about light is not how fast it moves, or how it bends, or even how it forces time itself to change. The real mystery is much closer than that. It surrounds every moment of your life so completely that it becomes invisible to your awareness. Because the truth is, you are not just watching these effects, you are living inside them. Right now, light is traveling from distant places, bouncing off surfaces, entering your eyes, and constructing the reality your brain believes is stable. It feels immediate, solid, reliable. Yet beneath that calm surface is a universe constantly adjusting itself. Every sunrise is more than a beautiful beginning. It is light crossing millions of kilometers of space, arriving with perfect consistency, obeying laws that stretch time and define distance. Every reflection in a mirror is a precise redirection of photons changing direction at exact angles. Every color you see exists because light shifts wavelength, and your brain translates those shifts into meaning. None of this announces itself. No sound, no warning, no visible mechanism. Just silent rules shaping the world. The ground feels still, yet the planet spins. Time feels steady, yet it flows at slightly different rates depending on motion and gravity. Objects look solid, yet at deeper levels they are mostly empty space, interacting through forces carried by light. Reality is far less rigid than it appears. The universe is not built like stone. It behaves more like a flexible fabric, stretching, bending, adjusting, all to preserve one cosmic constant. And somehow human senses evolved in a narrow range where these distortions remain hidden. Speeds are too slow to notice time dilation. Distances feel fixed because contraction is too small to detect. The bending of light becomes so familiar that the brain accepts it as normal vision rather than ongoing physics. The extraordinary disguises itself as ordinary. That may be the most unsettling idea of all, because it suggests something deeper. How many other rules are operating silently around you right now? How many truths remain unnoticed simply because they never disrupt daily life strongly enough to demand attention? Light has been crossing the universe long before the first human looked up at the sky. It traveled through expanding space, past forming galaxies, across darkness so vast it is difficult to comprehend. Some of the light reaching Earth tonight began its journey before human civilization existed. And still it arrives, precise, unchanging, obedient to laws that hold the cosmos together. Without light's constant speed, the structure of physics would fracture, motion would lose its limits, measurements would disagree, cause and effect could blur. Light is not just part of reality, it is one of the reasons reality remains coherent, yet the mind rarely pauses to consider it. Brightness fills a room, and attention moves on. Colors flash past, unnoticed. Reflections appear effortless. But behind that effortlessness is one of the deepest frameworks the universe has ever revealed. So the next time light spills across a wall or fades into evening, remember that something profoundly strange is taking place, not somewhere far away, but exactly where you are standing. And here is the thought to carry with you. If something as familiar as light hides this many secrets, what else about reality are we completely misunderstanding? If this journey expanded the way you see the universe, make sure to like this video and subscribe to our channel for more explorations that uncover the hidden rules shaping existence.